Hello, Math Analysis, and this is our exam review, and I've already started this problem. Remember, we are solving. We have a rational equation here. We need a common denominator, so I've already factored x squared minus 9, and its factors are x minus 3, x plus 3. So remember, I call these the what's missing problems. So what's missing here? Well, we have an x minus 3, so we're missing an x plus 3. So we do it to the bottom and to the top. This one has an x plus 3, and we're missing an x minus 3. So finally, our common denominators are here. So we're all set up. And I'm going to go ahead and distribute 2 times x plus 2 times 3. This is a minus, so it might be helpful to make this plus negative 4, and then we distribute the negative 4 at the top. So negative 4x plus 12. And now that it's all set up, we can happily eliminate that whole denominator. We have used it, and now we are losing it. So find those like terms in the numerator. 2x minus 4x is negative 2x. A positive 6 and a positive 12 is plus 18. Equals 8. So that is when we subtract the 18, we end up with negative 2x equals negative 10, x equals 5. X equals 5. And our restricted values would be plus or minus 3. Therefore, x equals 5 is a valid answer. Next equation, 2x minus 3 times 2x plus 5 equals 1. This is a quadratic equation that needs to be set equal to 0. So in order for us to do that, we need to do the multiplication here. So 4x squared, so positive 10 and a negative 6 plus positive 10 and a negative 6 is a plus 4x minus 15 equals 1. Set it equal to 0 by bringing the 1 over. 4x squared plus 4x minus 16. Now from here, this is quadratic. It appears that we can, first thing, get rid of a 4. And when we do that, we will have x squared plus x minus 4 equals 0. So are there factors of negative 4 that add up to 1? No, so it's not factorable. So let's go to the quadratic formula. So x equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 4 all over 2 times a. Simplify underneath the radical first. This is negative 1 plus or minus the square root of 1 plus 16, which is 17. And that is our answer, solving a quadratic equation with a quadratic formula. Moving on. Here we've got solve the square root of 8 minus 2x minus x equals 0. So anytime we have an equation with a radical in it, we want to isolate the radical and eliminate it. So of course this is a square root, so we will isolate the radical and square both sides. So the square root of 8 minus 2x equals x. Square both sides. 8 minus 2x equals x squared. And again from here, set equal to 0, and if possible, factor and solve. So since my x squared is positive on the right, I'm going to move everything to the right, and we will have 0 equals x squared plus 2x minus 8. And I believe this little guy is factorable. Factors of negative 8 that add up to 2 are x plus 4 and x minus 2. X equals negative 4 and a positive 2. And if we plug in the negative 4, negative 4 does not work because negative 4 times 2 will be 8, and 8 times the negative 2 would be 8. Oh, maybe I'm saying it wrong. Let's check it with writing. So this will be 8 minus 2 times negative 4. minus negative 4. Let's see what we've got here. This will be 8 plus 8. That'll be 16 plus 4. So 4 plus 4 does not equal 0. So I was speaking correctly. There we go. So that does not work. But the positive 2 does work, because 2 times 2 would be 4. 8 minus 4 is 4. Square root of 4 is 2. 2 minus 2 is 0. So 4 is extraneous. 2 works beautifully. Next, solving an absolute value equation. Whenever we have to solve an absolute value equation, we isolate the absolute value expression and then set up two cases. I believe we did one of these in class. So I'm going to first dump that 15, and I get negative 3 times the absolute value of 4x minus 7 equals negative 27. And then next we will divide by negative 3 and get the absolute value of 4x minus 7 equals 9. From there, we can set up two different cases: the positive case, 4x minus 7 equals 9, and the negative case, 4x minus 7 equals negative 9. And then solve. 4x equals 16, x equals 4. 4x equals negative 2, x equals negative 2/4 or 1/2. So our solution set is 4 and negative 1/2. Both of those will work. Next, negative 3 is less than or equal to 2x plus 5 over 2, which is less than or equal to 10. The first thing we can do here is realize that this is a compound inequality, and let's get rid of that 2 by multiplying everything by 2. So 2 times negative 3 is negative 6. The 2's cancel here, and we're left with 2x plus 5, and 2 times 10 is 20. So we can also get rid of the plus 5 with minus 5, and minus 5. So this is negative 11, which is less than or equal to 2x, which is less than 15. And our last step here would be to divide everything by 2. So we end up with negative 5.5 is less than or equal to x, which is less than 7.5. So our answers are bigger than negative 5.5 and less than 7.5, strictly less than. Now we're going to want to put this in interval notation. And interval notation, if you want to go to the number line first, that might be helpful. In interval notation, it's going to look like this. This is less than or equal to, that yields the bracket. This is strictly less than. This is the parenthesis. So there we go, compound inequality, and the solution is in interval. So we're finding all the zeros, and we find the zeros with the irrational root theorem. That's when we use the P's and the Q's. So this is in descending order: 4, 3, 2, 1, none. This is our P, this is our Q, and I'm going to ask you on the test to write all possible rational roots. So that's plus or minus P over Q. Factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And we will do that over every factor of 4, which the factors of 4 are 1, so plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And the next factor of 4 is 2, and then plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, all over the last factor of 4, which is 4. So of course, some of these repeat, and we can mark off those that repeat. So there's 1, there's 3, there's 1/2, and there's 3/2. So, all right, we've gotten rid of the repeaters. So those are all the possible rational roots. Now, I have picked one that works nicely here because I'm a nice person. And let's go ahead and go for it with positive 1 And let's test +1 with synthetic division. So 4, -1, 5, -2, and -6. Remember, we're looking for a remainder of 0 because that is will tell us that we're dealing with a real factor. So bring down the 4, and then yo mama's division. So 1 times 4 is 4, -1 plus 4 is 3. There's 3, there's 8, -2 plus 8 is 6, and 1 times 6 is 6. Look at that. Bam, we've got a factor. So our first real root is 1. And when I look at the depressed polynomial, remember that's what that's called. We just took it from a 4th degree to a 3rd degree, 4, 3, 8, 6. It looks to me like this might be a factorable quadrinomial. So 4x cubed plus 3x squared plus 8x plus 6. If we try to factor that by grouping, I think we have a winner here. So we can take out x squared and we're left with 4x plus 3. And on this side, if we take out a 2, we're left with 4x plus 3. Hooray! So we've got our first 0, and now we've got our 2 remaining factors. So 4x plus 3 is linear, and then x squared plus 2 is quadratic. So 4x plus 3, if we set it equal to 0, we get x equals -3/4, and x squared plus 2, when we set it equal to 0, use the square root property here, we find that it yields 2 imaginary roots. So 1, 2, 3, 4. Here are our 4 zeros for this quartic function. So 1, -3/4, which of course can be found right there, and then plus or minus I root 2. 1, 2, 3, 4. 4 roots. 2 are real and 2 are imaginary. The p's and the q's, remember, are our possible rational roots. So there we go, finding all the zeros. Let's keep going with another fun problem. Find a polynomial function that has the roots x equals 2 and 4i, and this polynomial function passes through the point -1, 51. So let's start with our first 0, which is x equals 2. So that, of course, is x minus 2. And then 4i. If x equals 4i, let's square both sides, and we get x squared equals 4 times 4. Remember to square the coefficient. That's 16. I times I is I squared, and 16i squared is -16. When we add that to the other side, we get our quadratic factor x squared plus 16, which I bet many of you already knew that. So now let's multiply these together because we're after our function. So that's going to be x cubed minus 2x squared plus 16x minus 32. So this is f of x, but we're looking for a function that is a multiple of this function that will pass through the point -1, 51. So let's plug it in, and really what we're after is an unknown coefficient a, the leading coefficient up there. We're after that. So a times, and we're going to plug in that -1 for x all the way through the polynomial. So -1 cubed is -1, minus 2 times -1 squared, which is 1, plus 16 times -1 minus 32. So 51 equals a times, so following order of operations here, we've got -1 minus 2 minus 16 minus 32. So this is -1, -3, -19, and -32. So we end up with 51 equals a times -51. So our a value is -1. So when we take that a value, which is right there, and we plug it in right there, we'll get our answer, which is f of x equals negative x cubed plus 2x squared minus 16x plus 32, because we have a negative leading coefficient of -1 that will force the polynomial to go through the point -1, 51. Now we've got some graphs, and let's zoom in a little more on the graph, because first of all, I want the domain, and the domain is all possible x values, so that it looks like the domain is starting here and ending here. We are solid on the left but open on the right, so -8 up to +8 parenthesis. The range values go from here to there. So we've got, and they're both inclusive, so bracket -4 to +4. Remember, the domain is read from the left to the right, the range is read from the bottom to the top. So if f of x equals -4, what's the value of x? So if we go to -4, which is here, that will be all infinitely many of those x values. So that will be from 2 to 8. So bracket on the 2 and then parenthesis on the 8. Next, we're going to evaluate. So 3 times f of -4. So f of -4 is 4. And 1/2 of f of 6. So that's going to be 1/2 of -4. That is 12. And then half of -4 is -2. 12 minus 2 is 10. That's using the graph and going backwards to answer questions about it regarding the function. Next, we are graphing a quadratic equation here, a quadratic function. It's going to be a parabola. This one is in vertex form, so we can see h and k, and of course we have an a value of 1. So our vertex here is going to be at x minus 4. Remember, set that equal to 0, and we find our h value is 4, and our k value is 5. So over 4, up 5, which is here. It's going to open up because our a value, our leading coefficient, is +1. So if you want to make a little table of values to help yourself out here, the y-intercept would be way, way, way off this graph, so we won't even worry about that. We do have an axis of symmetry, of course, which is going to go vertically right down the middle of that graph. So it would make sense to plug in a 3. Let's plug in 3 quickly. 3 minus 4 is -1. -1 squared is 1. 1 plus 5 is 6. So over 3 up 6, which would mean over 5 up 6. And let's shoot for 5 points. So let's also plug in a 2. 2 minus 4 is -2. -2 squared is 4. 4 plus 5 is 9. Over 2 up 9. And then we can use symmetry to get that other point. Here is our very nice parabola. Couple more graphing problems. Another parabola, this time though in quadratic form. This would be a good time to use the vertex formula. And the vertex formula is opposite of b over 2a, and then f of opposite of b over 2a. So let's plug that in. Opposite of -6 is 6 over 2 times 3, which is 6. So we have an x-coordinate of 1. And then f of 1 will be 3 times 1, which is 3, minus 6 times 1 plus 1, so that is -3 plus 1, that is -2. So we have a vertex at 1, -2. Over 1, down 2. We have an a value of 3 this time, so that is going to create a vertical stretch. So when we make an XY chart here, Let's plug in, obviously this time since we're so close to that y-axis, it's very easy to get that y-intercept. And when we do that, we can see what type of a stretch is going on here. So instead of back 1, up 1, we're going to be back 1, up 1, 2, 3, which means also a point there. So over 0, up 1. Let's plug in a 3, and it might even go off the graph this time. So let's see. 3 squared is 9. 3 times 3 is 27. So we've got 27 minus 3 times 6, which is 18. So 27 minus 18 is 9 plus 1. Whoop, just barely going to fit on. Over 3, up 10. A very, very tall, skinny parabola with that vertical stretch by a factor of 3. Now, we worked on these in class, and I told you that you're basically going to be graphing these just to the very best of your ability. What are we looking for here? First of all, we have a leading coefficient that is positive. And now let's find the degree of the function. So this first factor is to the second power. So that's x squared, and then times 1 more power of x. So that is going to be a total of x to the third. So if we were writing out this particular polynomial, if we were expanding it, its first term would be 1/2 x cubed. So if it is an odd degree polynomial, that means our end behavior will be opposing. And since our leading coefficient is positive, this is going to be an increasing function, which means overall from left to right, the function will be increasing. So we do have some zeros here, and because this is going to have a multiplicity of 2, we know that we're going to get a bounce at x equals 2, but we are going to pass through x equals -3. And let's go ahead and let's plug in 0 to get our y-intercept, and then we can graph this function. So when x is 0, that's 0 minus 2, that's -2 squared, which is 4, so 1/2 of 4, and then times 3, half of 12 is 6. We've got a y-intercept at +6. So once again, we're going to bounce at 2 and pass through 3. And we are increasing, so our function is going to look something like that. And we're done.